Oh, okay. All right. So we are working on, let me start over what I had said earlier before I started the video. We're on making comparative inferences about population. Comparative means comparing. Okay, so we're going to be comparing two things. And what was inference again? It's inferring. What is that?
A way of thinking without like knowing.
Taking a guess?
Kind of taking a guess, making a general statement about something. So we're going to be making a general statement about a comparison of two different samples. So one person's going to sample something, another person's going to sample something else, and we're going to make an inference that compares the two. We have a video first.
Yeah.
Nice enthusiasm, Landon. Here we go. Oh, I think I turned it down.
How can you use data displays to compare populations? Think about this question during the lesson.
Oh, quickly about this question. Data displays. What ways can you display data? What ways have we learned so far? Donnie? Dot plots is one. What else? Mateo? Box and whisker plots. Donnie? A bar graph. Okay, the two we're going to be, well, really the main one we're going to be looking at today is box and whisker plot. That's the easiest way to compare data is with a box and whisker plot. So that's going to be our majority of today.
Finn and his cousin Jonah attend different middle schools. They compare the number of hours students at each school spend on homework each week. Finn and Jonah each conduct a random sample of 20 students who attend their schools, and then list the data in order from least to greatest. What can Finn notice about the time spent on homework?
Okay, so I'll zoom in a little bit here on their, oh, I thought it was
Finn's
going to stop.
first step is to display.
There's 20 numbers up there, so it's kind of hard to look at. With a list, it's not very easy to give exact answers. But is there anything in general you notice between Finn's school and Jonah's school? Making an inference is really something that you notice. What do you notice? Eliana?
Jonah's school most of them spend a lot more time than Finn's school.
Yeah.
Or at least there are more who spend more time.
That's kind of what I notice as well. They both start out at 1, and they both end at 11, so their minimum and maximum is the same. But look how quickly Jonah's school jumped up to 5. Whereas at Finn's school, they don't get to 5 until way out here. Can you see that? To me, it looks like Jonah's school, those numbers are quite a bit higher in his sample than at Finn's school. Okay, so step number 1, display the data in a box plot. Box plot is a box and whisker plot. It's just a shortened name for it. So we're going to use a box plot. Identify median and quartiles. What is median? This was on your quiz yesterday, Hannah.
The middle.
It's the middle number. And where do you find the median on a box plot? Or a box and whisker plot? Where is the median? Ivan?
Middle.
In the middle? How do you represent it though? Where's the median? Claire?
The line in the middle of the box.
It's the line that's somewhere inside of the box, okay? And then what are the quartiles? It says find the median and the quartiles. What are the quartiles? Mateo?
So there's 3 numbers. So you put them from least to greatest. There's the middle, that's the second.
Yep.
And then on the left side, the middle of that is the first, and on the right side, the middle of that is the third.
Okay, good. So if I were to find the middle, I don't know where the middle is, but let's say the middle is right here. That's quartile 2. We call it the median, but it is the second quartile. Quartile 1 is the halfway mark of the first half. Quartile 3 is the halfway mark of the second half.
The data in box plots. Before he can construct either box plot, he needs to identify the median and quartiles for each data set. The box for Finn's data set is between 3 1/2 and 6 1/2. The median is 5. The box for Jonah's data set is between 5 1/2 and 8. The median is 7. Which measure of center is more useful to describe Finn and Jonah's data sets?
If you have a box plot, which measure of center can you use? If what you're given is a box plot, which measure of center do you even have? I need more of you to listen to my question and come up with an answer. My question again was, if you have a box plot, one of these, which of these is even on that? Because only one of them can you find from a box plot. Mean, median, or mode. Which one is on a box plot? Landon?
Median.
Median. That's the only one that's on a box plot. So it's the only one that I could use to compare the two data sets. Whoops, not that one. Median.
Why is the median a more appropriate measure than the mean? The median best describes the data because both data sets have outliers.
I think I was just talking something else.
I guess not. Okay,
Then
so
a more
stop,
appropriate
stop,
measure
stop.
than the mean.
Okay, so let me zoom in on this a little bit so you can see what's happening. These are the box plots. Didn't we say that Jonah's numbers were higher on that list? Yeah? So what do you notice about Jonah's box plot?
Further up.
The box itself is higher up. Quite a bit, yeah, it's quite a bit higher. So the median is higher. The median here was 5. The median here was 7. Okay, so the median is higher. Also, the box itself is higher. Do you guys remember? I think we talked about it. Range is how far from beginning to end, right? Do you remember what it's called when it's just from here to here? I'm pretty sure we did that vocabulary. It's something range. So all of it is range if you go from beginning to end. But if you go from the left side of the box to the right side of the box, it's called something else. Eliana?
I don't remember, but quartile range?
Oh, that's really close. Do you know what the word for, like, in between is?
Middle.
No.
Median.
It's a word within the word thing, so that might not be.
Give us word part.
What's that series?
Do you know what interstate is?
Yes.
Inter?
Inter.
What does interstate mean?
Between states.
Hannah?
Interquartile?
It's the interquartile range is what it's called. But what does interstate mean? You know, if you have a road that's called an interstate,
States. Between.
it is within the state. So an interquartile range is in between the quartiles. So it goes from quartile 1 to quartile 3, and it's in between them. That's what interquartile range is. So this one has its interquartile range is higher on the number line. What do you notice about the width of the boxes? The actual width of the interquartile range. Are they similar or are they different?
Different.
Which one has the larger interquartile range? I think Finn's does. Isn't that the larger rectangle?
Yes.
Okay. But it's still lower. The numbers themselves are lower. Okay.
The median best is.
Jump up there.
The next step is to compare the two data sets. The line for the median of Jonah's data set is to the right of the line for the median of Finn's data set. So Finn can say that the median of Jonah's data set is greater.
Okay, it would not be an inference if you said that Jonah's median is higher than Finn's median. It's an accurate statement, but it's not an inference. That's just a math statement. An inference is, what does that actually mean? what does it mean that Jonah's median is so much higher than Finn's median? Donnie?
Jonah's students spend more hours per week than Finn's
Yes.
schools.
This being higher means that the number of homework hours per week at Jonah's school is more than the number of homework hours at Finn's school. But it has to have a meaning to it in order to be an inference. You can't just state the math facts. Yes? Is that fine? Okay, let's finish up with what he's
The
saying.
box for Finn's data set is longer than the box for Jonah's data set. So, Finn can say that his data is more spread out or has greater variability.
Okay, so new vocabulary term. I want you to write this down as the first thing for today. It's this right here, greater variability. Right there, those two words, greater variability. In this case, and really what it means is that interquartile range, that box, is a bigger box. That means kind of the numbers are all spread out. It is right here. Data is more spread out. That's the definition for it. Data is more spread out. Okay, are we done?
Yeah.
All right, take a look at this box plot. First of all, what's it comparing? You need to get the general idea of what you're looking at. Jude?
Seventh grade students and sixth grade students.
Okay, what about them?
How many there are?
Nope.
No.
No?
Height.
Height. It's the height of them. So we're looking at the height of 7th grade students compared to the height of 6th grade students. How would you compare their medians? What could be your comparative inference about the medians? Mateo?
There's more 7th graders that are taller.
Okay,
There's like
so
more,
the median tells us that 7th grade students are taller than the 6th grade students. But not by much, right? They're really not very far apart. But we could say that the median tells us that the 7th grade students are generally taller than the 6th grade students. What about variability? What comparative inference could you tell me about the variability? Variability is like the stretch of data points. So what could you tell me there? Eliana?
The 7th graders have a lot more variability than 6th graders.
7th grade has a lot more variability than 6th grade. Why do you say that? What were you noticing?
Because the Boxplot is bigger and the range is bigger.
Okay, so this interquartile range here, the box itself is significantly larger than the 6th grade box, and the range itself is significantly bigger. So really, what does that mean? What does it mean that the 7th graders have a greater variability? Claire?
they have more, like, they have smarter kids and, like,
Yeah, they have some quite short kids and some quite tall kids. Whereas the 6th graders are much more closely related in their heights. Does that make sense? Are you with me? So greater variability means you've got, a broad span of answers. Whereas 6th grade, everybody's answers were kind of closely related. So if we want to answer these questions, it said that the median of the blank grade sample is greater than the median of the blank grade. Which one was greater? 7th. So the median of the 7th grade sample is greater than the median of the 6th grade sample. Second question, the blank grade sample has greater variability. That was 7th grade. Okay. Yeah, this is the same box plot as Finn and Jonah earlier about the number of homework hours they were looking at their schools. This is the other part that we have to look at. I'm gonna draw a picture instead. I'm gonna have you guys draw a picture. What are we on? 6.3 Comparative Inferences. Okay, so in a box plot, let me just draw, I want you to draw a general box plot. Not on a number line or anything. Just a generic box plot, okay? So when I'm ready to sketch that, we're gonna label and put some number things to this also. Okay, this line right here, what's that called?
Median.
That's the median. Okay, so I'm gonna label that median. This is called the Interquartile Range. Just to get some labels in there for you, something to look back at. Exactly related to what range normally means, but it's just looking at the length of the box. Okay. What does median mean again?
Middle.
Median means middle. So when you split something in half, it splits it exactly in half, right? That's what the median does. It splits the data points into two equal halves. So what percent of the data is less than the median? When you split something in half, what percentage is on the left of it? What percent of the data points are on the left? Hannah? Never mind. Claire? It's 50%. So this section from the minimum to the median is 50% of the data. It might not even visually look like 50% necessarily, but 50% of my numbers make up the first half of the box plot. What percent make up the second half? The other 50%. It has to add up to 100, so we got 50% is in the first half, 50% is the second half. Do you need more time for writing? Okay, on the left side of the box, this is called the first quartile. What percent of the data would be on that left whisker? If the first half is 50%, what percent is just the whisker? Hannah? 25% of the data is here. How much of the data is the left side of the box? 25. It's like a quarter of them. A quarter of the numbers make up the whisker. A quarter of them make up the left side of the box. What percent on the right side of the box? 25% again. And the right whisker is also 25%. So you can think of this as the median splits it in half. Half of the data, but the quartiles split it into quarters. 25, 25, 25, 25. Bailey? What? Oh, that's okay. It doesn't matter that it's there. The video still is fine.
That's why Nathan uses.
Yeah.
You should.
You should probably like actually sign in.
I know, but I don't wanna sign in on there with mine, cause then it's a class iPad,
Yeah, that's what happens to
you know, and then
mine.
the other kids can go on, or kids can go on it, so I don't know. I don't know what to do.
Make it deep.
Okay, so here's the general idea of how a box plot splits the data. So let's go back to Finn and Jonah's problem. So hopefully these numbers make a little more sense. 25% of the values are on the left whisker. Why do they say that 50% of the values are in the box? Why does the box contain 50% of the data? Bless you. Why does the box contain 50% of the data? Somebody else, come on, listen to my question. Why does the box from the left side to the right side contain 50%? Brayden?
Because it has two 25%.
Exactly, that's 25, that's 25.
And 25 plus 25 is 50.
There we go, so the interquartile range contains 50% of the data, and then the right side is the last 25%. So this can be kind of grouped together or broken apart or talked about in any manner that you need to. Ooh, my voice went. Okay, let's. Okay. Next example.
What's the line tonight?
All right. I think I'm gonna have you sketch this box plot. This comparative box plot, so the two of them. So make a number line that goes from,
This is example one.
yeah, this will probably be our one full example. So you need a number line that goes through 22. They counted by even numbers.
How many examples do you think that we'll do?
It might just be this one.
Oh, yeah, we do more.
I don't know. I'm not sure. I know you'll need time to draw this, so I'll give you the time that you need. This is comparing heights again. It's not heights between grades though, it's heights between classrooms.
Are we supposed to draw the,
Go quickly while we're waiting.
we're supposed to do the boxes, right?
Yeah, draw the boxes as well, yes.
I messed up so bad.
Oh, yeah, that doesn't work. Make sure you're watching where the whiskers start and end and where the box begins and ends.
Wait, I'm just making sure.
Mm-hmm.
On the top one, on the end of the box,
Mm-hmm.
is on 14, right?
It looks like it, yep.
Okay, I'm just making sure.
Yeah, it looks like they're all at whole numbers.
Okay.
Except for the whisker.
The whisker of the top one.
70, yeah.
Yeah, that's at 5, at a half of the segment. second box done. Can I do it one more time? Are you just redoing something? Okay. So while a few are finishing that up, this is not height of people. Can anyone tell me why I know that? Why is this not the height of the people in the room?
It doesn't say anything about people.
Why is it not height of people? Jace?
It says rooms.
It says rooms, yes, but we're talking about sampling people within the room. But why is it not the height of the people? Brayden?
Cause like it's only like 12 and 22. So like if it was the height of people, they would probably be like 1 or 2 feet.
Right.
tall.
This is height in inches.
What is it measuring?
Even babies are at the upper end of this. Like, this isn't even heights of babies. That's not how that works. What this is these are 2 science rooms, and they're growing plants, and these are the heights of the plants that they're growing. So that's what the box plot is about. They've collected data from plant growth, and this is at a certain time frame. They collected the data of how tall everything is. I'm assuming it's for a science experiment, like they used a certain kind of fertilizer or something, or they used a certain kind of something, and they're figuring out how they did. Sam, are you done with yours now? Yes? Okay. So what we're going to do is I'm going to give you a number of different statements, and we're going to decide whether they're true or false. So underneath your box plot, I want you to make a column where one column is true, the other column is false. And we're going to put statements into the 2 columns.
Wait, we're gonna like write stuff in there?
Yeah, we're going to write stuff in there, a statement. So make sure it's kind of a wider table. Left column is going to be true, right column is going to be false. Something just like this, true, false. But you're going to put statements in here, so make sure it's a wide table. Okay, statement number 1. It's in this blue box down here are going to be the statements. So 7G, they're talking about the name of the room. 7G has a greater median height. Does 7G have a greater median height? Is that true or false?
False.
How come? Ivan?
You see on the box that 7D is a little more than 7G.
Nope, they're essentially the
I think
same.
they're actually equal. I think they're really equal medians, but either way, 7G is not greater. So write 7G has a greater median height under your false column. 7G has a greater median height is false. I hope you can see everything up here. I'm trying to enlarge what you need to see as we go. Okay, next statement. 50% of 7G are between 8 and 14. 50% of 7G, so we're looking at this box plot, and they're saying it's between 8 and 14. Well, here's 8, here's 14. Does that begin and end at quartile segments?
No.
No, it doesn't, so we can't say that. That's another false statement.
It's all even, it did move over just
I
two inches.
think, isn't 50% of 7D between 8 and 14?
Yes.
8 and 14 goes from beginning to end of the box on 7D, but not 7G. So that's a false statement. one? Oh boy. Next one. Room 7G has the tallest plant.
Yeah.
Does 7G have the tallest?
Yes.
Yeah, because 7G goes out here to 20, 7D stops at 18, so 7G has the tallest plant. That's a true statement. So write room 7G has tallest plant under your true column. Room 7G has tallest plant. Next one. 75% of 7D plants are 8 inches or taller. How would we find 75%? Because we only looked at 25s and 50s when I was writing information earlier. How would we get 75%? If quartiles split it into 25s, Eliana,
You just add another group.
I need another quartile, another group. Every group is 25%, so how many groups do I need?
3.
I need 3 groups to get to 75%. So they're saying that 3 groups of 7D are 8 inches or taller. So 8 inches in 7D is here. Do we have 3 groups more than that?
Yes.
1, 2, 3. So yes, we have 75% of the data being more than 8. So put that one under your true column.
How many of these are there?
I don't know.
Totally fill boxes.
Yeah, I think it might be 8 total. I think it's 4 and 4.
I
mean,
have a question for you, but I
Yeah.
can wait.
If you could, please. We'll be done in just a few minutes.
Okay.
All right, next one. Whoop, come on, zoom in.
This one is
50% of 7D are between 8 and 14.
had this.
We need 50%, so we need 2 segments, and it says between 8 and 14 of 7D. So here's 7D, 8, 14. In there, do I have 50%? Yeah, that's the interquartile range exactly. So 50% of 7D, that third one here is under a true column. Donnie, are you writing all these down? Okay, you are. Are you looking at them ahead of time?
Yes.
Okay.
I think the next one's gonna
Next one's gonna be false.
You think so?
Just by what we
It's
are
gonna be
pattern.
true.
No, false.
If it's true, then the next two are gonna be false.
I don't think we are. No.
True.
No. Everybody got done? Bailey, are you done? Yes? Okay.
This one goes to false.
Sam, you're good? All right. Okay, next one. Room 7D has the shortest and the tallest.
No.
False. 7G, we already talked, 7G has the tallest, so we know that's not true. So that's going to go under the, false column.
This one's gonna be false.
That's gonna be true.
When, yeah, I don't have anything to judge this one on, so
We have 1 spot left under true and false.
I'm just gonna stick with maybe either. I have no
False.
choices left.
It's gonna be
It
true.
definitely has to be
I don't
false
know.
or true.
It does have to be false or true.
It cannot be
Doesn't it?
maybe.
All right, next one.
What is it?
Okay, this is another 75% question.
False.
75% of 7G plants are shorter than 12 inches. So here's 12 inches, that's your median. So what percent is less than the median? 50%. They said it was 75. So that's our false statement.
I was
Oh,
right.
right.
Oh, yeah. I was right.
I said false at the very end. That's
No, he said false because soon as we
So that statement should have been that 50% of the plants were shorter than 12 inches, not 75.
I know that one.
And it doesn't include 12, so it's even less than 50%.
No, the median is the mark that splits it 50 and 50.
Oh, true. And this one is gonna be true.
So I would assume our last one's gonna be true, but let's look and see what they say
It's
about
gonna be
it.
false.
Median.
False.
Oh,
Not true.
False.
Median heights are equal?
is that true?
We talked about this.
We did talk about that. That one is a true statement. Median heights are exactly equal. There you go. Median heights are equal. True statement. No, that one's right. That one's right.
No, I wrote it on the other side.
Oh,
I put
did you?
This one's false.
Oh, I see. Okay. Median heights are equal. That's a true statement.
I mean, they had it pretty even. Maybe like 1-7.
Okay, so let me summarize the lesson a little bit. The percentage part is part of it, but the other part was that if you want to make a comparative inference, you can compare by talking about their medians, and you can talk about their comparison by their variability. What was variability again?
More or less.
What they
What do you mean more or less?
Like a range.
It's their range. How much of a spread of answers they have. So how far apart are the minimum and the maximum? That's a greater variability. So you can make statements on both of those things. Tonight you have online homework. So you guys do have a little bit of time. Why don't you go ahead and get your iPads out and get started.
This, look at
We
it.
definitely cancel others.
Oh, I do, don't I?